Welcome back to Arxflix. Today, we're diving into an intriguing research paper titled Compression Represents Intelligence Linearly. This study explores the relationship between large language models, LLMs, and their data compression capabilities, shedding light on a fascinating theory that superior compression is indicative of greater intelligence. Here's a pivotal figure from the paper that shows a nearly linear correlation between average benchmark scores of various LLMs and their compression efficiency. The idea that compression might be directly related to intelligence isn't new. Researchers like Hutter, 2006, have long posited this. With LLMs becoming advanced text compressors, the questions arise: can we measure intelligence via compression? And if so, how strong is this relationship? The study focuses on three main abilities to gauge intelligence: knowledge and common sense, coding, and mathematical reasoning. In their experiments, they used 30 public LLMs from various organizations, evaluated across 12 benchmarks. Let's dig into how they did it. They measured compression using bits per character, BPC, evaluating how well these models compress text from external corpora. This metric reflects the efficiency of encoding text in a lossless manner. The results showed that compression efficiency was almost linearly correlated with the model's performance on various benchmarks related to knowledge and common sense. For assessing knowledge and common sense, text from Common Crawl was used. The benchmarks included HelloSwag, Triviaka, and MMLU. The Pearson correlation coefficients were impressively high, with HelloSwag at 0.877, Triviaka at 0.947, and MMLU at 0.888. Moving to coding, LLMs were evaluated using data from GitHub. The correlation remained strong, underpinning that better compression led to higher coding abilities, as reflected in benchmarks like Human Evil, MBPP, and DS1000. The mathematical reasoning tests revealed similar correlations. However, some models showed signs of having been trained specifically on benchmark data, highlighting the issue of overfitting, which was identified using the MinK-prob method. Overfitting in mathematical benchmarks, particularly on datasets like GSM8K and Math, was marked by anomalies in MinK scores. These suggest certain models, like the Quen series, were likely exposed to training data. The paper also explores how varying the type of compression data affects the linear relationship. Using mismatched corpora weakened the correlation, but their chosen datasets provided robust results with simple heuristics. For instance, compressing Common Crawl text poorly predicted performance on mathematical reasoning tasks, and Python code didn't correlate well with general knowledge benchmarks. How many characters are needed to compute BPC reliably? The paper found that around 30 million characters were sufficient, indicating that a relatively small corpus can yield significant insights. What about tasks requiring multiple abilities? The study applied the program-aided math reasoning method to GSM8K, combining Python and RZivmath corpora. The results again showed a strong linear correlation. This mixed corpus performed better, exemplifying the need for aligning compression data with the benchmark's specific domains. These findings advocate for using compression efficiency as an unsupervised and reliable evaluation metric for LLMs. However, the study does acknowledge several limitations, such as focusing solely on base models and short to medium context tasks. To conclude, superior compression indeed seems to indicate greater intelligence, marking a step forward in understanding and evaluating LLMs. The study's open-source datasets and pipelines will undoubtedly facilitate future research. Thanks for watching Arxflix. Don't forget to like, share, and subscribe for more insights into cutting-edge AI research. See you next time. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.